Okay. All right. So when we start out, we talk about immunology. We have to branch into the innate immunity versus adaptive immunity. So when you think of innate immunity, that is basically the same in all of us. There's no memory to it. It's kind of like, if you want to think that the cells are kind of like the army, they're your first line defense. If there's any sort of infection, regardless of what it is, that's what's going to be going to try to alleviate the problem, right? There's not a lot of premeditated thought. It's just like, let's get to the infection. Let's do what we can to isolate it, to kill it, to prevent it from going out systemically, okay? So contrarily to that, the adaptive immunity is going to be your memory cells, right? So this is going to be like when you get some sort of infection, is your body able to make these memory cells to be able to recognize it if it happens again. So this is more of an advanced system. These are when we talk about our B cells, our antibodies, and our T cells and how they develop. So it's going to be more of a long-term response. So this is going to be different between person to person, depending on what you're exposed to, what vaccines you have and whatnot. So the innate arm, again, we're talking about those phagocytic cells. We all know macrophages, neutrophils. They're going to go to the site of infection. A lot of times it's bacteria. Just when you think of bacteria, you just think of a ton of cells. You want to just eat them up as soon as possible. Whereas viruses are kind of like a little sneaky, right? So you may need some sort of adaptive immunity to kind of counteract them. So the first line is always going to be your skin, any sort of physical barrier. And then the second line defense is going to be this innate arm, this innate response to everything. So primarily you're thinking of your granulocytes, your neutrophils, basophils, eosinophils, your macrophages, stuff like that. And then when we talk about the adaptive immune system, it's more of a long-term response. We have our cell-mediated immunity, like our CD8 cells, and antibody-mediated, so like our B cells and our plasma cells. So yeah, again, you get this memory formation. So if you get the virus one time, you want to be able to recognize it if you get it again. So whereas the first time you get an infection, it may last, this specific viral or bacterial infection, it may last 2 weeks. If you can develop memory to it, the next time you fight it off, you can knock it out in like 3 days. So, and there's a lot that goes into the adaptive immune system, because how does your body actually form this memory? How do you even recognize it? How are you able to form cells that are just floating around long-term to be able to identify it? And we'll get into that. And y'all will get into that a lot more towards the final as well. So as you would expect, the innate immune system is going to be quick. You can respond to it in hours, whereas the adaptive immune system has to form this memory. But as I said, when you have a response to this, to a repeat infection, the adaptive immune system is going to be those memory cells that are like, okay, we've seen this already. We need to be able to address this. And again, these lymphocytes, the lymph nodes, are going to be where these antigens and antibodies come together, and you're able to isolate it, right? So I guess that's a good point. Let's look at this. And I just want, this is very basic, but I want to make sure you understand. So like the antigen is from the virus, right? So if so it's from the infection. So virus, bacteria, whatever, right? So if we say that the infection, let's say the virus is a car, the antigen could be like a tire or whatever the body can recognize in the circulation, that's actually your antigen. And your antibodies are what the body makes in response to the infection, right? So like I said, the antigen, if the virus is a car, maybe the antigen is the tire or the brake light, or for instance, for COVID, they use the spike protein, right? So the COVID virus has these little proteins on the side, and they developed vaccine to this. So you would consider these little spike protein an antigen, okay? So the whole point is, if these antigens are floating around, the body needs to make memory, antibodies. And by doing that, you can neutralize this complex. That's the whole goal, okay? So that being said, let me ask you this. If we, and hepatitis B is a good example for this. If you check the blood and you're positive for antigen, what does that mean? That literally means you have, so in regards to hepatitis B, that means you have an active infection, okay? You can't have antigen, parts of the actual virus, floating around if you don't have an active infection. So what if I said you have IgM? What does that mean? Well, we know these are antibodies, and these IgMs are the first antibodies that are made, and we'll get into it a little bit more later. But this means there's an acute infection, okay? So let me just change colors real quick. If we say we check the blood, we're positive for antigen, and we're positive for IgM, all right? Patient comes in. You could tell the patient, you have an active infection, right? Because of the antigen, but you have also started making antibodies, right? These IgMs, these are the first antibodies made. Now, what if you tell the patient to come back in a couple weeks, your antigen's negative, IgMs are negative, but IgGs are positive, all right? You could tell the patient, since there's no antigens there, the virus isn't present, okay? You've cleared the virus, but, and then IgM isn't present, but IgGs are. So remember, this class switching is the change from one antibody to the other. So when you switch from IgM to IgG, you're showing long-term immunity. So your IgGs are long-term. So this is going to be, so you've cleared the infection, but you've developed some long-term immunity. So for now, that's going to help you understand this idea. So remember that IgM, in order to have this long-term immunity, this IgM to IgG process has to happen. And this is the phenomenon of class switching. Okay, and then aid, if we'll get to that, but the aid is what aids in doing this. Okay, so the point I wanted to make is you could actually take serum, you could take the different components of this and look at the patient and you could see what exactly is going on. Well, you could even say, well, what if the antigen's present, so we have an active infection, but IgG's present. So not only is the antigen there, but why do we have long-term immunity as well? So that could be a sign of chronic infection. You've had time to develop these long-term antibodies, but you've also, the antigen and the virus is still present. So with hepatitis, any sort of chronic infection can lead to liver disease. So this is the point of understanding these differences in antibodies and whatnot. And we'll touch on it a little later. I just think a general overview kind of helps me piece things together.